I am Nathan Morris. I work at Niab as the Farming Systems and Soil Specialist. I lead this project on nitrogen and sulphur fertiliser applications on milling wheat and the effect on grain protein and baking quality, funded by the ADHB. The UK flour mills process around 5 million tonnes of wheat, of which 85% of this is grown in the UK. There is currently rising demand for UK homegrown wheat. Flour is a vital source of vitamins and minerals for human health. Wheat grown for milling must achieve quality characteristics including Hagberg falling number, specific weight and protein, which have a significant role in producing the final flour quality. The current recommendations for nitrogen in wheat, as shown here from the ADHB Nutrient Management Guide, are based on the Soil Nitrogen Supply Index and the soil category. The nitrogen max limit for winter wheat in nitrate vulnerable zones is 220 kilos of nitrogen per hectare. However, an extra 20 kilos is permitted on shallow soils and an extra 10 kilos for each half a tonne of grain yield expected over 8 tonnes up to a maximum 13 tonnes a hectare is permitted. For milling wheat, an extra 40 kilos of nitrogen is also permitted, and it has been shown that 40 kilos of nitrogen can increase grain protein by up to 1%. Data from the British Survey of Fertiliser Practice shows that average field application rate of nitrogen in winter wheat is around 182 kilos on average for the past 5 years for non-milling wheat and around 208 kilos in milling wheat. Therefore, there is a difference of 26 kilos of nitrogen a hectare, which is less than the 40 kilos of N recommended in the current nutrient management guidelines. Sulphur nutrition is also important in milling wheat. Sulphur is important because nitrogen fertiliser may not be fully utilised where sulphur is deficient. Correct sulphur fertilisation improves the quality of the grains, and baking experiments have shown that low volume can increase significantly if bread-making wheat is correctly fertilised. Therefore, the nitrogen-sulphur ratio needs to be below 16:1 to avoid a reduction in bread-making quality. This chart shows the deposition of sulphur across the UK. Many areas are now sulphur deficient and require sulphur fertilisation to crops. In addition, acrylonide formation in wheat is linked to levels of the amino acid asparagine. The optimum sulphur rate to minimise acrylonide formation in bread-making wheat has been shown to be 50 kilos of SO3 per hectare. This project aims to update guidance on the nitrogen and sulphur fertiliser use for winter milling wheat to achieve optimum grain quality and milling specifications for a range of varieties, soil types and growing environments. The specific objectives are to evaluate the grain quality, primarily grain protein and specific weight, and the responses to nitrogen and sulphur fertiliser application rates and timing. We will also assess the impact of nitrogen and sulphur fertiliser rate and timing on dough rheology and baking performance, including, for sulphur, the production of asparagine. From this, we will develop the basis of new recommendations for nitrogen and sulphur fertiliser applications for milling wheat quality. This project will run a series of field trials over 3 years looking at winter milling wheat. These will be undertaken on a range of soil types and geographic environments. 2 trial series will investigate nitrogen rates and timings, and this will be made up of 3 varieties, 2 from Group 1 that is KWS Sayat and RGT Skyfall, and one from Group 2, KWS Siskin. The second trial series will look at nitrogen and sulphur rates and timings. Varieties will be from Group 1, KWS Sayat and RGT Skyfall. A number of quality parameters will be investigated, including grain protein, specific weight, Hagberg falling number and grain nitrogen sulphur ratio, dough performance and baking rheology, and the production of asparagine. Specific treatments for the first trial series, looking at nitrogen fertiliser rates and timings, we'll look at the 3 varieties with treatments of a control, so no nitrogen applied at the RB209 recommendation for yield alone, and then a series of rates of additional 40 kilos of nitrogen at either growth stage 32 to 35, at 37 to 39, or as a foliar urea nitrogen applied at growth stage 73. We will also look at an additional 80 kilos split, either 40 kilos at growth stage 32 to 35 and a further 40 kilos at growth stage 37 to 39, or we will look at an application of 40 kilos of nitrogen at 37 to 39 and a further 40 kilos of foliar nitrogen at growth stage 73. The final treatment will look at a total of 120 kilos above RB209 applied at 40 kilos at growth stage 32 to 35, further at growth stage 37 to 39, and a foliar of 40 kilos of nitrogen. All treatments will have magnesium sulphate applied to supply 50 kilos of SO3 for sulphur. Trial Series 2 will study the interaction of both nitrogen and sulphur. In this trial series, rates of nitrogen will be applied either as 40 kilos above RB209 at growth stage 37 or 39, or as 40 kilos of foliar nitrogen applied at growth stage 73. Sulphur will be applied from 0 to 75 kilos of SO3, or as splits of either 50 or 75 kilos of SO3 applied at timings from pre-growth stage 30 through to growth stage 32 to 35. This project is in year 2 and results to date should be treated as preliminary. In 2019, despite nitrogen rates of up to 345 kilos of nitrogen per hectare, very few of the grain samples achieved 13% protein. No consistent trend from the addition of sulphur at reducing asparagine levels were found, and high Hagberg falling numbers that were suitable for milling were only achieved at 2 of the 4 sites. The wet weather at harvest was likely to have contributed to this. The 2019 season was a difficult season to achieve high protein for good baking performance. As a result, gluten strength was notably lower and led to weakness in the breadcrumb structure. Further trials in 2020 and 2021 will help to strengthen the data set to achieve the basis of new recommendations for nitrogen and sulphur fertiliser in milling wheat, and on completion the project will deliver new information on recommendations for nitrogen and sulphur fertiliser applications for winter milling wheat, applicable for both the ADHB nutrient management guide as well as other industry nutrient guides or systems. Finally, I would like to thank the project partners. These include both research, industry, seed breeders, fertiliser manufacturers and millers.